this video we will be seeing the solution for the LeetCode problem, find all anagrams in a string. So this is Leetcode-438 and we'll be continuing with the explanation. So what is the explanation? So simply first of all, before the explanation, let's read out this problem statement. Given true strings s and p, return all start indices of p's anagram in s. So p is a small substring given to us, or a small string given to us. You have to find whether this string is containing the anagrams of it. So what is the approach to us? So let's think about it. So a b c. Okay, so what we can create is this can be easily solved with the help of sliding window. So I check, like, if I encounter c, so it's like, for example, the brute force would be like, if I'm going through all the alphabet, if I'm going to c, I'm checking that whether c is there in this or not. Then I'll check for b. Is b there? Is a there? Okay, c, so this is there, c is there, and a is also there. So this cba is anagram of abc. So anagram is basically any string that is originated from some string, and which is like, it is a permutation of a string. So if we change the order of the characters within the string, we will get the same string. So if cba is a string, so abc is the anagram of this string, or we can say the vice versa. So we are seeing this, that we can observe one thing, that this problem corresponds to sliding window fixed size, because the size of the window or the string over here is 3, and we should always search for the consecutive 3 elements. So what we can do is, we can the brute force would be to slide over every element, like C B A, then B A E, then B A E B, then E B A. So what we are doing basically is, this would be costing us big O of n into 3n. So this would be costing us 3n, but we can also solve this with the time complexity of 2n. So how we'll solve that? So basically we'll include this window of size 3, and then we'll check in the hash map. We'll initially construct a hash map, and then we'll check for that this string is there in that hash map or not. So if it is there, then we'll return this count, and if it is not there, we'll remove this the last element, the first element that we added to this window, and we'll add the next corresponding character to this window. So then we'll check for BAE. Is BAE there or not? And then if it is there, then good, we can add the ith value of it, and then we'll check for AEB, and so on. So we'll check like this. Now AB, so P is AB, and output should be like over here 0 1 2. So how is it 1 2? So AB is our anagram of AB, then BA is anagram of AB, so 1, the starting index of that anagram we have to return, and then again AB is anagram of AB. So this is how we are doing it. So the approach here is, we use sliding window of size length p to find anagrams of p in s. So this is the fixed size window, and then we count the frequency of characters in p. Move a window size length p across s, updating character counts. Compare windows count with p's count. When count matches, record the start index. So we can record the start index. So basically we are comparing the hash map. Now in this example, we are given the string CBAEBABCD, and P is ABC. We have to check for the anagrams of this. So this was our initial, like, we'll check for CBA. This would be our window size, and it matches with AB, 0 index. So what we'll do is BAE. So what we have slided it by one place, so BAE, this window is slided. Then we continue sliding till we reach this end, so 0 1 2 3 4 5 6. So we this is the last index till which we can expand this, like we can move forward, because ACD, if ACD is there, then if we expand this, so we'll be out of index and we'll not be having the window size of 3. So what we'll do is we'll expand it accordingly and we'll store all the indices. Time complexity is big O of n, so big O of 2n corresponds to big O of n time complexity, where n is the length of the string. Space complexity is big O of 1, since we use the size of array of length 26. So we are specified in the question that we are using the lowercase letters, so the time complexity of building the hash map of frequency count with these letters would be big O of 26, because 26 is a constant, so that would again be equivalent to big O of 1. And sliding window ensures each character is processed at most twice. That's why I told initially that we were having the time complexity of big O of 2n. So let's move on to the code. So this is our code, finding all anagrams. So what we did in this is we created a list of array list. This would store the result, and this is the prior condition that we'll check, because if the string in which we have to find the anagrams is smaller than the p dot length, then there is no purpose to find the anagrams, because it is not having the characters at least equivalent to the other string. So this would not be meaningful. Like it is just like we are given a string a b c a v and d, suppose, and the other string is p q a v d p q r. So we are saying that we have to find the anagrams of this in this. So this is not the correct statement, because this is having the size lesser than this. So of course we can return the list over here. This would of course be a empty list. Now what we are doing is, next we are initializing a empty hash array, and we are taking it as length of 26, and by default this would be containing every element will be 0. So next we are doing is we are iterating over the p string initially, of which we have to find the anagrams, and we are storing the count of those characters into our hash array. So how we are doing is that it minus, this is the ASCII value of small a, and by this we will be able to do it. So this is, I guess this would be easy in both C++ and Java, also Python. And int duplicate, then this is the duplicate array that we have created, and duplicate is of size 26, and we will store only till the p dot length. Like if a string is so long, we'll only store the frequency count of first 3 letters. Like if p is of length 3, so we'll store the frequency count of first 3 letters in s. Now what we are doing is, this is just initialization of a variable, and now what we're doing, this is the actual code that we have, that is the logic over here, that if array dot equals ch dot duplicate ch, we'll add I. So we'll add I in this. I is the 0th, the starting point of this sliding window. If it is not, then, or if it is, so we'll check next. So duplicate of s dot caret I. So s dot caret I, the starting character of the sliding window, we'll eliminate this from the window by decreasing the frequency count by 1. And if I plus k is less than s dot length, so this is the checking condition that that we discussed in the slide, that this should not exceed the out of index, like it should not exceed the length, and it should not go index out of bound. So what is this condition? I plus k is should be less than s dot length. So this is just a simple logic that we saw in the iterations. And while seeing the index also, we can say this, that I plus k, if when the last character is I plus k is less than s dot length, so that means we can say that we can skip move to the next iteration. So this is for that. And what we'll do, we'll add the next corresponding consecutive adjacent element or the character into our window. So this would be the logic over here, and this way we are sliding the window. So the pattern to recognize over here is that this window is of fixed size, so hence we can solve it easily. And the other problem, which is permutation of a string, is similar to this problem. So I hope it is clear. Thank you.